All right. Assignment 6-4. I'm rocking my mock trial shirt. Here we go. Number one. All of these are integration questions where you have to think of the strategy you're going to use to integrate. So like things I look at. The derivative of the denominator does not equal the top. This is not in the form of arctangent because we're not adding. There's no square roots. It's not arcsine. What direction am I going to go? So it's factorable in the denominator. So if I factor it, I have x plus 1, x minus 1. So I'm going to do this using partial fractions. So I'm going to separate it into x plus 1 and x minus 1. And then I'm going to solve for a and b. So if I was going to make common denominators, I'd have to multiply the first fraction by x subtract 1, top and bottom. The second one would be x plus 1, top and bottom, and I'm going to make that equal to 1. Next, I'm going to let x equal positive 1. That will make it 2b equals 1, and when I divide, b is equal to 1/2. I'm also going to let x equal negative 1. And in that situation, I got negative 2a is equal to 1, because that's 0. And then divide by negative 2, and I get negative 1/2. Now I'm going to come back into this question, and I'm going to rewrite it with a and b. So I'm going to rewrite it in this form. So I have a, and I'm going to put it in front to make it easier to factor. So I got negative 1/2, and then 1 over x plus 1. That's a. Then I have b. Again, in fact, I could have put it in front of the integration. I'll do that next. 1/2 times b is over x minus 1. All right, so we're in a situation now where we can do this. So I'm going to take the negative 1/2 in front, and then what's left, I can just integrate with a logarithm. Plus 1/2. Again, this 1/2 can go in front. That's just a logarithm. And then plus c. And you've integrated. All right, let's try it again. I think it's okay, right? It might even be a little simpler than integration by parts. But whatever. We need to have the skill to do all of it. Let's look at it again. So as I look through the options, obviously at some point you need to press pause and try it first if you're going to learn it. So as I go through the options, the only option I see, so I take the derivative, it doesn't match. It's not in the form where I see any inverse trigonometry. So I'm going to factor it. So that's negative 2 and positive 1. And then I'm going to set up two fractions, one for a for x minus 2 and b for x plus 1. And then make that equal. And then I'm going to multiply by x plus 1. I'm going to multiply by x minus 2. And then I'm going to use the zeros to solve this. So for x equaling negative 1, I get negative 3b is equal to 3. So when I divide, b is equal to negative 1. It's double checking. If x equaled, what would be the other one? Positive 2. Then 2 plus 1 is 3a. That's 0, and that's equal to 3. Divide, and a is equal to 1. So I'm going to rewrite this. So I can start with a. That's over x minus 2. The next one is negative, and that's 1 over x plus 1. And then these are just logarithms. Double checking. All good. All right, number 3. I feel your strength. It's getting stronger. The force is strong within you. Get this calculus done. Again, the first thing I look at, if I take the derivative of the denominator, does it match the numerator? And it's close. It's 4x subtract 1. There's no common factor to make it match exactly, so instead I am going to factor this. To make it simple, to factor, 2x and negative 1 are prime. Like the only way to multiply to 2x is 2x times x. The only way to multiply to 1 is 1 times 1. And then thinking which one must be negative and which one must be positive to get that answer. So negative 1 times x, this is inner. If I do the two outer, like foiling, 2x times 1, together they make positive x. So we want this to be positive and this to be negative, so that we have negative 2x plus 1x that matches. All right. Next, we're going to set this up. And we're going to find what a and b equal, so I can integrate it. So a is going to use x minus 1, b is going to use 2x plus 1, and I'm going to make that equal to 5x minus 2. We're then going to use the zeros. So positive 1, that's 0, that's 3b, equals 3. So when you plug in 1 for x and then divide, and b is equal to 1. On the other side, I'll do that over here, this is negative 1/2. So be careful when it's a fraction. Negative 1/2, subtract 1, divide by 2. So negative 1/2 and negative 1 is negative 3 over 2. This is negative 5 over 2. Just takes a moment to solve this one instead. I'm going to write this with common denominators. So 4 over 2, that's negative 9 over 2, times the reciprocal. This took a little bit more effort. And that gives me positive 18 over 6, which is equal to 3. So now I know what they equal. So b is 1, a is 3. Now come back here and rewrite it. So I'm going to write that 3 in front and then integrate 1 over 2x plus 1. So whatever a is, I write in front and just use positive 1 in the numerator. When you multiply it together, it's still 3. I'm going to do the same thing here. For b, it's 1, so I don't need it. And that's over 2x. No, x minus 1. All right. Now integrate what you see. The derivative of 2x plus 1 is 2. So it was a 1, it became a 2, so I need a 3 over 2 and then a logarithm with the denominator. This one's ready to go. The derivative is equal to 1, so that's ln x minus 1 plus c. All right, number 4. Okay. So if I go through the process of seeing which strategy to use, the derivative, no inverse trig, none of that. I am going to factor the denominator. That's x squared minus 1. One more time. That's x and a difference of squares. We got this. And then it's going to be ABC. How fun. So A is with x, B is with x plus 1, and C is with x minus 1. And that's equal to 2x squared plus 2x minus 2. And then I need to solve this. We're going to use the zeros again. Well, first of all, we're going to create the numerator. So this needs x plus 1 and an x minus 1. This one here needs x and x minus 1. And then the last one needs x and x plus 1. and make it equal to the numerator. So first of all, we're going to use the zeros. So if we start with x equaling positive 1, 1 take away 1 is 0, so all of this is 0. 1 take away 1 is 0, so all of this is 0. Did I do this one? Yeah. So what that leaves me with when I plug in 1 here is 1 plus 2. That's 2 times 1, so that's 2c. And then if I plug 1 in here, that's 4, take away 2. So c is equal to 1. That's what I got so far. I'm just looking at the answer key because it is a little bit off. Oh, I know what's happening. Okay. So I'm totally perfect so far. So the next one I'm going to use is negative 1. So if I use negative 1 plus 1, that's 0. This one would be negative 1, and negative 1 is negative 2, times negative 1 is positive 2b. This one is 0. And then negative 1 times 2 would be negative 4 plus 2, which is negative 2. Divide, and I get negative 1. The last 0 is 0. So if I plug in 0, the b and c are done. Plug in 0 here. 1 times negative 1 is negative 1a. 0, 0, that's equal to negative 2. Divide, so a is equal to 2. So I have my numerators now. I'm going to rewrite this. So the first one over x was a, and I'm going to write it in front. The next one is b. I'm going to write it in front, the negative 1. b is over x plus 1. And then the next one, c, is over x minus 1. And then that's what I'm going to integrate. So this is 2 ln x minus ln x plus 1 plus ln x minus 1 plus c. And it's done. Number 5. Integrate ln x, ln x. Well, I know it's not partial fractions because we don't have fractions. Done. Different way. If I see ln x times ln, or 3x times ln x, the hook would come inside the logarithm. It doesn't match. This is going to be by parts. U is going to be ln x because I can't integrate ln x. That means du is 1 over x dx. dv is going to be 3x. So when I integrate 3x, I get 3x squared divided by 2. Come back to here. What's the formula again? Let me write it down. U times v subtract v du. That's what we're doing. So ln x times 3x squared over 2 minus v du. All right. I'm going to clean this up just a little bit. The first part, I don't care. It's clean enough. This part is the part I need to clean up a bit. X squared over x gives me x on top, so it's just 3 over 2x when I simplify it. And then integrate it. So I'm going to add 1 to the exponent and divide. Plus c. This would also be 3 over 4. Perfect. Number 6. Integrating x squared sine 3x. This again, if I look inside the trigonometry and take the derivative, that's where the hook would come from. This is not a hook. So this has to be by parts. So the only time u wouldn't be the algebra part is for a logarithm. So u is equal to x squared. The derivative is 2x dx. dv is sine 3x. And then when I integrate that, the hook is 3, so I need a 1/3, and then it's negative cosine. And then I follow the formula, which is u times v, subtract v du. Now, we're still in a situation where the derivative of what's inside the parentheses is not like terms here. Can't be a hook. And so I need to do by parts a second time. So just for this, I have negative 2/3 x and the derivative of that is just negative 2/3. dv is cosine 3x. So the integration of cosine 3x the hook is 3, so I need a 1/3, and sine is positive when you integrate. And now I'm going to put the answer down here and finish it. So it's x squared negative 1/3 cosine 3x minus, and again, in fact, a negative times a negative is positive. So why don't I just make this positive? So then I don't have to worry about it. So a negative times a negative is positive. Now u times v is positive 2/3 and 1/3 sine 3x minus the integration of v du. Oop, I need a dx there. All right, we're getting there. So we have x squared negative 1/3 cosine 3x plus 2/9 sine 3x. We have 1/3 and 2/3, so it's negative 2/9 the hook here should be 3, so I need a 1/3 in front with that, so it'd be negative 2/27. And then the hook can be ignored or circle it. And there you go. Honestly, that's the longest situation for by parts, right? When you have to do it twice and with trigonometry. What a great little question. Not so little. All right, number 7. We gotta get this done. You know, do you ever, like, when you eat sushi, maybe you don't eat sushi, they have this pickled ginger, and so when you eat sushi and you want to move on to a different type of sushi, you eat this pickled ginger, and it kind of cleanses your mouth so that you don't have the same fish taste in your mouth and go to a different one. So think of this now to eat your pickled ginger so that we can move on from number 6 and now have a new palate in your mouth, so now we can move on to number 7. All right, you ready? Let's move on to number 7. This is not by parts. What do I see here is I see a monomial in the denominator. And so with a monomial, I can then easily separate this into different fractions. So that's what I'm going to do right now, and then I'll clean it up. So make it simple. There's my different fractions. I have a 2. Now this is 1 subtract a half. That's 1/2. Root x divided by root x, that's 1. And then this is going to be x to the negative 1/2. It's good practice. Putting the constant in front kind of cleans up the integration a bit for you. And then the rule, we're going to add 1 to the exponent, and then divide or times the reciprocal. 1 is just x. We're going to add 1 to the exponent and then divide or the reciprocal and then plus c. That's a good answer. It's 4/3, it's 6, but you can leave it exactly like that. Number 8. Integrate 2x plus 1 to the 6th. I like these. Look inside. Where does the hook come from? What a great question to start with when integrating. So the hook comes from inside the parentheses. That's 2. That's 1/2 to undo it. So I start with 1/2 and just do the power rule. So that means I add 1 to the exponent and divide, and I'm done. If they all would be like that, right? Number 9. When I see this lesson, to me, what we've done so far in calculus, this is like one of the most important ones to practice so that you have the ability to understand which method to do and practice. That's the only way you see this and get stronger, is the practice you put into it. I could do the same thing here, but the problem is if I take the derivative of what's inside the parentheses, it's 6t. I don't have like terms. I could use a really fancy technique here, but I don't want to. I want to be simple. I'm simply going to FOIL this. So because it's squared, that's easy to expand. That's going to be 9t to the 4th. Multiply it together. You can draw a box or FOIL, whatever, but there's a pattern with the binomial theorem. Square it, multiply and double the answer, and then square it again. That's a simple way to expand a binomial. And then just integrate each one at a time. So add 1 and divide. Add 1 and divide. And again, you don't have to simplify it. I know that simplifies to 2, but you don't have to do that. 10. All right, as you should do for every question, you should press pause and do your best. Look at it, think about it, and then press play. So I'm going to rewrite it like this. At this point, if you can integrate it, press pause and do it. Recognize that the derivative of what's inside the parentheses, the base, gives you the hook. And the derivative of ln y is 1 over y. So this is the proper hook. So all I have to do is add 1 to the exponent and then divide or the reciprocal plus c. Number 11. Try to see if it's a long, not too bad. All right. How much room I needed for number 11. So we're going to go through some trig lookalikes to think they look similar but different strategies. When I have a fraction, the easiest thing to look at is if it's a logarithm. The derivative of 1 is 0. The derivative of tangent theta is secant squared. It is perfect. So this is a logarithm. Just write down the denominator with bars plus c, and then ignore the hook or the numerator. Number 12, another lookalike. So again, if I take the derivative of the denominator, it is not going to match. So the derivative of tangent is secant squared, not tangent squared. What could I do instead? Well, there's a substitution I could use, or I'm trying to think what direction. What's the best direction? For number 12. Yeah, see, that's what I would do. So the denominator is actually a trig identity. So secant squared is actually equal to 1 plus tangent squared theta. That's a trig identity. So we can replace it with secant squared and then recognize that that is just 1, and then you can integrate it. Well, that's an interesting way. I don't want to do the other method. That's way more involved. Number 13. Again, a lookalike. What are we going to do? So give it a shot. Like, be patient, press pause, try your best. I'm going to do the first step for you. Now look at it. Can you do it? Press pause. The derivative of 1 plus tangent theta, we've said, was secant squared. So this is the right hook. So all I have to do is take 1 plus tangent theta, add 1, and divide, and you have the integration. Number 14. Press pause and try. So I'm going to use that trig substitution, that identity substitution, that 1 plus tangent squared is secant squared. And then recognize that secant squared divided by secant squared leaves me just with tangent. And then this is a logarithm. It's a negative one. It's a rule. And it's negative ln cosine theta. If you forget that rule, you could write it as sine over cosine. That's where it comes from. And then the derivative of cosine is negative sine. So then ignore the hook, and it's a logarithm with the denominator. Same thing. Number 15. So the derivative of the bottom does not match the top. I see the power term on top is more powerful. You know what else I notice? I think I can simplify it. Let's see if that's a good direction to go. To factor and simplify. No. So, because the power term on top is 1 bigger than the bottom, we're going to divide. So x plus 1 into 2x squared minus 4. So power term divided by power term. That's 2x. When I subtract, oops, I get negative 2x. Subtract 4. So then power term divided by power term is negative 2. The remainder is really important, so I'm going to rewrite this again. So we have negative 2x subtract 4. The remainder would be negative 2x subtract 2. Be careful when you subtract a negative. You're adding, so the remainder is negative 2. So I'm going to start with 2x minus 2. And then the remainder over x plus 1. And then integrate each one by itself. So for 2x, that's x squared. For negative 2, it's negative 2x. This one's a logarithm, so think of negative 2 in front and then the logarithm of x plus 1 plus c. All right, number 16. I'm going to integrate e to the exponent cosine 3u and then sine 3u. So for this one, I see the hook comes from the new exponent. The derivative of cosine is negative sine. So I need negative sine 3u. And then the hook, again, would be 3. The derivative of what's of 3u. That's the hook that I need. So look carefully between the two. So it was a 1 and became negative 1/3. And then this whole hook you can ignore or circle it, and the answer starts with negative 1/3, and then the rule for e is copy it. And you did it. Number 17. Challenge yourself, write it down, and see what direction would you go. And then when you're ready, press play. And then see what direction did we go in the same direction? And again, the real key is sine monomial in the denominator. That's one term in the denominator. It gave me direction in terms of simplifying this. So I'm going to clean this up. We're going to subtract the exponents. So that's 3x. We're going to subtract. That's 1 take away 2. That's negative 1x. And then we're just going to write this as negative 2x here. So one at a time. The hook comes from the exponent. So the derivative of 3x is 3, so it needs to be 1/3. And then you can ignore or circle the hook. And then the rule is copy. The derivative, or the hook here, is negative 1, so I need a negative in front, which makes that positive. And then it's just that. You can circle the hook to make sure you don't include it. The last one, the hook is negative 2. So what it was over what it became, I needed to divide by negative 2. So that's just negative 1. And then you can ignore this, and it's e to the negative 2x plus c. Number 19. No, number 18. That was number 18. What did I do? Did I ignore it? Oh my goodness. Haha. So this was 18, and I decided, I'm not doing 17. Do you want to do that? I'm just not doing number 17. I saw it. I'm not doing it. I have those feelings too. I'm not going to do it. I'm not going to do it. Alright, so what do I see when I do this? I'm going to do it. The hook comes from here. So the derivative of sine is cosine. And then it has a second hook. The derivative of x cubed is 3x squared. And then I'm going to rewrite this sine x cubed to the 3/2. And then look carefully. So I see cosine x cubed. Yep. I see x squared. I see a 3. I can take care of that. It was a 1. It became a 3. And then all of this you can circle and ignore. And then the answer starts with 1/3. And then this is the power rule. This is the base. So it's just the power rule. So we add 1 to the exponent. And instead of dividing, it's good practice to use the reciprocal. And you have your answer. I did it. Number 18. I did 18. 19. Number 19. So we're going to integrate 4x, the square root of 1 minus x to the 4th. All right, press pause and think. So the first thing you might think of is, if I write it calculus friendly, is the derivative of this going to match? And the answer is no. So if I see 1 subtract x to the 4th, square root, it is in the form of arc sine for me to look at. So u is the square root of x to the 4th, which is x squared. Du would be 2x dx. And then a would be the square root of 1, which is 1. And so when I look at 2x dx, it's almost right. So I'm going to change it to a 2, which makes this a 2, because 2 times 2 is 4, or 4 divided by 2 is 2. And then I can ignore that. And the rule is, you start with 2, arc sine, which is a fun way to write inverse sine, and then it's u over a. So x squared over 1, and then plus c. This only happens with practice. It's not an accident to remember these things. 20. All right, I'm going to give you a moment. Look at it, think about it, and think what direction you're going to go. All right, this is going to be a little different. So we have x plus 5. So I'm going to write it as x over x squared plus 16 and 5 over x squared plus 16. Go from there. Press pause. Could you integrate it from there? So this is a logarithm. The derivative of x squared plus 16, 2x. To unhook it, it needs a 1/2. In this situation, it's not going to help. The derivative of this is not going to match it. I'm thinking arctangent. So in this situation, if it was arctangent, u would be the square root of x squared, which is x. A would be the square root of 16, which is 4. And it's adding, so it's in that form, and I can see that then the derivative of u is 1 dx, and now I'm set. So instead of 1 dx, I have a 5, but I can put the 5 in front and get 1 dx. There it is. And now this is just This is just arctangent. So start with a 5. It starts with 1 over a, and then arctangent, and then u over a, and then plus c. All right, try number 21. When I look at it right away as a trinomial, it's not factorable into the denominator. I'm going to complete the square. Like, I see it and I feel it. I'm going to complete. I see a trinomial. It's not factorable. So I'm going to complete the square and write it in the form where hopefully I can do arctangent. So how do I complete the square here? We got this. So I'm going to take negative 10, divide by 2, and square it. That's negative 5. That gives me 25. So I'm going to both add 25 and subtract 25. This now is factorable. It's now a perfect square. That's negative 5 squared. And that's 7. Making sure I did my math okay. And then we can get our values we need. So u is going to be t subtract 5. The derivative of u would just be 1 dt in this case. And then a is the square root of 7, which is just root 7. So for arctangent, we start with 1 over a. That's perfect. Just leave it that way. And then it's u over a plus c. All right, 22. I know it feels forever, but it's been 38 minutes. Is that forever? Doing calculus. You need to take that pickled ginger. You need to clean your palate. It's okay to press pause and not do this all in one. I really think that if you do 20 minutes of calculus a day, your work would be done for the week, and you'd be consistent and you'd learn more. So you don't have to do it in one sitting. All right, think what direction we're going to go here. The derivative of x squared is 2x, but it's plus 4. So it's not going to match there. It is factorable, so I'm going to go by parts. So this is, x plus 4. So we have x, and we have x plus 4. And then I'm going to solve for that. So to get common denominators, a is going to be matched up with x plus 4, and b is going to be matched up with x, and then make it equal to the numerator. Use the zeros. X is negative 4. What do you get? You get negative 4b. This is negative 8 plus 12. Divide, and b is equal to negative 1. The other 0 is 0. So I get 4a equaling 12. So a is equal to 3. And now go back. So again, at any point, press pause. So I'm going to use these values and go back. So we got a is 3. B is negative 1. So again, a and b, and I put those values in front to make it easier to integrate. So the integration of 1 over x is just ln. The integration of 1 over x plus 4 is ln. And then plus c. 23. we got to the end of this page. Less than an hour. Hey, this is a little different because it's a definite integral, but we can do that at the end. We're going to integrate this by, well, what do you think? Press pause, think about it. It's going to be by parts. So u is 2x, du is 2, dv is cosine x, so v, the integration of that is sine x. And then I'm going to come back here, and we're going to go u times v minus, and then we got to use the bounds, v du. Oops, make sure you remember that. I keep forgetting that dx. Then, and this should be dx too, by the way. Integrate this. So I'm going to put the 2 in front, and then when I integrate sine, I get negative cosine. So it's going to make it positive, and then it's from 0 to pi. Oops. Let me do this again. Let me look at it. One mistake that I don't want to make is how I apply what's happening here. So when I have an understanding of this from 0 to pi, the whole thing that you integrate, like that whole answer that you ended up with, we need to use all of it from 0 to pi. So technically, this would be 0 to pi with a vertical line, and we're still trying to integrate that. And so first plug in pi. Subtract, and now plug in 0. And then do you know your unit circle? So the value of sine at pi, it's the y coordinate. Sometimes having a visual helps you. There's pi there on the left. The answer is 0. So that's 0, and that for the x coordinate is negative 1. So this is negative 2. The value of sine at 0, so there's angle 0 there. The y value there is 0. The x value there is 1, so that makes it negative 2. So altogether that answer is negative 4. Perfect. All right, turn the page. We'll see how much further I can go today. Some review questions. It's always okay to take a break. Then come back to the video. Alright, you first. Press pause. I'm going to use what's called the quotient rule. That's the bottom times the derivative of the top minus the top times the derivative of the bottom. Oops, that's an x. And then the bottom squared. Oh, well, there you go. That's all I got. Mr. D Math over and out. Until next time, I'm really proud of you for doing your work. And then we have one more video that we're going to finish off the assignment. Till next time.